OpenTelemetry is a powerful observability framework that can help you gain better sight into what your application is doing. If you want to learn more about the theory behind OpenTelemetry, go ahead and check out this video I made called What is OpenTelemetry and subscribe while you're there. But now that we know we want OpenTelemetry in our application, let's take a look at how we actually implement it. For this, I'm going to be using a Node.js application and we're going to instrument traces, metrics, and logs. Let's get started. Here in VS Code then, the first thing we need is a Node.js application that we want to add OpenTelemetry to. So what I've got here is a very basic Express application. It's actually from the OpenTelemetry documentation example. But you can see it's got one very simple endpoint, and that's just /roll_dice. And this takes in a search query parameter of the number of rolls we want to do. And the API here is simply going to go ahead and return an array of those dice rolls. So I can actually go ahead and test this out if I just run the application. So for that, I'm using TSX. So it's going to be source/app.ts. And then if I go over to Insomnia, I can test out my endpoint here. So if I hit send, you can see we're getting an array back of 4 dice rolls, and that's because that's what I've asked for in the search parameter. So there you go, very simple application. This code is a little more complicated than it needs to be though. You can see this roll the dice function is actually in another file, and it also calls off to another function called roll once, which just handles some really simple math logic there. The reason for the overcomplexity in this application though is just so I can show you how OpenTelemetry works on a more complex application and how you can scale it to pretty much any size node application. This way I can show you things like nested spans and how they help you trace requests through multiple layers, and things like context propagation and log correlation as well. But we'll get to all of that when we go ahead and implement it. The first thing we need to do is go ahead and get the Node SDK set up. So we need to go ahead and install a few packages. So if I head down to the terminal here, I'm just going to expand this out. Let's close the application I've currently got running. I'm going to paste in these packages that we need. The first one is just the Node SDK for OpenTelemetry. Then we have the API as well. Another one is this auto instrumentations node package. I'll get to that when we actually go ahead and implement this, but it's really cool. Then we've got the SDK for metrics, the SDK for traces. Then we've got resources and semantic conventions, which are essentially some helper packages just to help us out with those OpenTelemetry semantic conventions. And we'll go ahead and hit enter on this. Now we'll add in the logging and exporters a bit later, so we'll come back and install a few more packages, but for now this will do. So the next thing we need to do is go ahead and create a file called instrumentation.ts. So that's going to be instrumentation.ts. This is going to be where we set up the Node SDK, which lets you initialize OpenTelemetry, and it has a load of several default configuration options as well, which are going to work in the majority of cases. So if I just minimize the terminal there. First thing we need to do is go ahead and import Node SDK, and that's going to be from the Node SDK package. So that's Node SDK from OpenTelemetry and then /SDK-node. And we need to go ahead and use this. So we have const SDK, and this is going to be equal to new and then Node SDK like so. And then inside of here, we have the configuration options. The first configuration option we're going to set up is the trace exporter. So where do we want our traces to go from OpenTelemetry? For this, we're going to use the debugging ones of the console exporter. So that's going to be console span exporter here. Essentially, it's just going to go ahead and console log our spans or our traces, and also our metrics as well, we'll be doing in a bit. This is mainly used for debugging purposes. As it says here, it's for diagnostic use only. When you actually go ahead and run this in production, you'd want to use an exporter like the OpenTelemetry protocol exporter, which we'll also be taking a look at a bit later, and how you send that to OpenTelemetry collector. So now that we have our traces covered, let's go ahead and add in our metrics as well. For that, you need a metric reader. Now for the metric reader, we're going to go ahead and add in an import. What I'm going to do here is I'm going to do import, and then we'll type from, and then this is going to be from OpenTelemetry SDK metrics. And here we're going to go ahead and import the periodic exporting metric reader. And we're also going to go ahead and import the console metric exporter as well. Now that you have those two things, you can go down to the metric reader, and we can say we want a new periodic exporting metric reader. And then inside of here, we're going to add in some configuration options for this metric reader. And that's simply going to be the exporter. And then that's where we're going to add in the console metric exporter like so. What we've done here is we've simply said for our metrics, we want to use the periodic exporting metric reader here. You can see this one, it just collects our metrics based on a user configurable time interval and passes the metrics to the exporter. So you can actually go ahead and change the interval that you want your metrics to be read at with this export interval milliseconds here, but we're going to leave it as the default. Go ahead and save that. So now that we've got that, we need to go ahead and set up the auto instrumentations as well. As I said earlier, this is actually a really cool library. Essentially, it's going to go ahead and create the traces and the metrics for you in a load of popular libraries and frameworks. There's actually a list of the ones that it supports at the moment. So here on NPM, I'll leave a link to this in the description down below. You can see the supported instrumentations with this auto instrumentation package. And it's got things like AWS Lambda. It's got things like Express, which is going to be important for us. It's got things like HTTP, which we're also going to use. But it's got things like Redis as well. And as I said, it's got a load of popular libraries and frameworks already set up. Now, if we go back to the code, essentially what it's going to do is, as I said, it will set up the traces and metrics for us. So for our example, with a HTTP endpoint, if someone hits that, it's going to go ahead and create a trace for that entire endpoint call and also log some of the metrics as well. So we don't need to create them, but we will also look at how we can create our own custom ones as well. But to set up the auto instrumentation, all we need is instrumentations, and then this is going to be an array. And then you want to type in get node and then auto instrumentations, and that's going to be a function. And then we also need to go ahead and actually import this. That's going to be import. And then that's going to be get node auto instrumentations. I wish it was giving me the helper to actually go ahead and do this. And that's simply going to be from the OpenTelemetry package of auto instrumentations node like so. So we can go ahead and save that. Now, another thing that's really useful to do is go ahead and define a resource. So this is just going to attach some really helpful information for OpenTelemetry. So for our resource, we'll say this is a new resource, and that's going to come from the resource package we installed. And then this resource here, we're going to want to use our semantic conventions. So I'm going to go ahead and import them. It's going to be import. What I'll do is I'll go ahead and type this out just so we get some helpers. So from OpenTelemetry semantic conventions, and the two we're going to be using, it's going to be the attribute of the service name. So it's going to be service name, and then we're also going to be using the service version as well. So it's going to be attribute underscore service version like so. So now we can go ahead and actually use these as keys on our object of our resource. And you see this relates to service.version. Now remember, the semantic conventions essentially just help you make sure that you're talking the same language across all of your different languages, services, and platforms as well. So on this resource then, to use it as a key, we simply need to wrap it in our square brackets. We can say the attribute of service name here. So let's go ahead and say attribute service name. This is going to equal to, and then we can set this to something that we want. So I'm going to call this dice roll app like so. And then you can also add in a version. The version isn't actually required, but it's very useful for production purposes. I'm just going to set this to 1.0 since obviously this isn't actually a real application that has a version. And then we can go ahead and complete that configuration there. So that's actually all of the configuration we need for now in the Node SDK. But the last thing to do is make sure that this file actually starts the SDK by doing sdk.start like so and going ahead and saving it. So this should be what your file looks like. You can see we've got the imports up here, and then we've got the SDK defined down here. We need to go ahead and run this before our application now though. Now, one thing to know about this instrumentation file is we need to actually go ahead and run this before our application code, just to make sure that it's capturing the whole life cycle of our application. Now, one way you can commonly do this is by using the require flag on Node. You can actually do that if you're using common JS modules. Since we're using ESM modules here, so our package.json here has type of module, we're going to be using the import flag. They essentially do the same thing. The import one is if you're using ESM modules, and then the require one is for common JS. So if I go over to the terminal, the way we can run instrumentation.ts is simply by doing pnpm DLX. So this is how you're going to run your code. If you're just using Node, so you're not using TypeScript or anything like that, the same command will apply. You'll just have to replace where I do TSX with simply just Node. So I'm using TSX here since it can just run TypeScript without having to transpile it. You could also use a tool like TSNode as well. So what I'll go ahead and do is I'll say -- import. Again, if you're on CommonJS, do -- require. And then we need to pass it the instrumentation file. So for me, that's in source and then instrumentation.ts. Then we can also go ahead and run our application now and hit enter. Now, as I said, all you'd have to do is type node and then the -- import bit. So everything after here, just replace this here with node if you aren't using TypeScript or you're already transpiling the TypeScript. Let's go ahead and hit enter. It's going to go ahead and run the application. If I go over to Insomnia and I send one request here, we should see after a second or so that we'll get that trace logic coming in from that request that we made, and that's coming from the auto instrumentation that we set up, since I haven't actually added in any instrumentation of my own yet. So if I go ahead and actually take a look at what this trace looks like, we can see at the very top here, we have our resource and it has the attributes of that resource. So we've got the service name, which we provided, the same with the service version. It's then got some information about the OpenTelemetry version that we're using of the SDK there. So it's using the Node.js one. It's got some information about the process itself. So what it's running on, the architecture, the host machine. You can see we've got the instrumentation scope. So what actually picked up this trace. And you can see for us, that is the instrumentation of HTTP there. And then we've got the trace ID. Then we've got the name, which was a GET request. So this was a GET request. You can see we've got the attributes of that request now. So we've got the URL that was hit, the host, we've got the method, we've got whether it was a success. So down here it's 200, and various other bits of information as well. So you can see there how that auto instrumentation package really helps us out. And what just came in at the end here as well was some of our metrics. You can see we've got a histogram metric here, and that measures the duration of inbound HTTP requests. So it's already created one since that was on a periodic timer. And you see here it says for a HTTP GET request of status code 200, here is the histogram data for that. So it took 10.7 milliseconds here, and you can see all of them did because the min and the max, it was only one request. And then you can see we've got our buckets as well. And as I said, that all came from that auto instrumentation library. So let's take a look now though at how we can actually go ahead and implement our own traces, our own metrics, and also link in logs to this as well. So we'll start out by looking at how we can create our own traces. And the first step to doing that is acquiring a tracer. To do that, if we go to our app.ts, since we're already set up with the Node SDK, we can simply call the getTracer function to acquire a tracer. So we go into the app.ts here, I can type const tracer, and that's simply going to equal to trace, and that's going to come from the OpenTelemetry API. And then we'll go ahead and run getTracer like so. Now we need to provide this with some information, so that can be a name and a string. This is simply going to be the scope name. So this is the instrumentation scope. Now an instrumentation scope is meant to represent a logical unit within your application. For example, the package, the module, or even the class name. Now the name is required, but the version necessarily isn't. So what we'll go ahead and do in here is I'll simply type in, let's say, dice roll and then server. And then I'll also give it a version though, and I'll call this one, let's say 1.0. So there we go, we've got a tracer. Now a tip from OpenTelemetry is to only call getTracer in your app when it's needed, rather than setting one up and then exporting it throughout your whole application. So don't write export const tracer here and use it throughout your app. You're going to want to go ahead and call getTracer in sort of your logical units of work or in each instrumentation scope. So we'll go ahead and add one to dice.ts as well. So we go to the top of this file. I'll go ahead and type const tracer, and that is going to equal to trace, and we'll go ahead and import that from the OpenTelemetry API, and that's going to be getTracer. And now I'll give this an instrumentation scope name as well, and I'll call this dicelib as if it was one of my libraries. So now that we've got that, we can go ahead and create our spans. Now a span is meant to represent a unit of work or operation. They're the building blocks of traces, and there's actually two methods that you can do this using the API. You have the start span function and start active span. We're going to be using the start active span function, and you'll want to use this in most cases as it takes care of setting the span and its context as active as well. So let's go ahead and use this now. So in the roll the dice function, let's say I want to create a span out of this function. Well, first I'll go ahead and return something from this function. Then we'll say tracer and then start active span. So you can see our two functions there. And then inside of here, we're going to give this a name. So I'm just simply going to name this what the function was called. So it's going to be roll the dice there. And then we need our callback function here. So what's called in the context of the span. And you can see here, what we'll do is we'll provide it with span. Then we'll import the span type, and that's going to be from the OpenTelemetry API there. Once we've got that, we're going to go ahead and encapsulate the logic that we want to be tracked by this span inside of here. So we'll go ahead and paste that. And you see where we previously had return result, we now have that within this span function here. So that means that this is going to return that result from the API. So it's not going to change the behavior of the code. It's just attaching a span to this logic of work here. Now, an important thing to remember to do though is to actually end the span. So we need to do span.end here where it makes sense. So you can see just before we return, we can say we can stop tracking this now as it's essentially finished. And we can do span.end like so. Now, before we take a look at this in the console, let's see a few more things we can do to make our traces better. First, we're going to go ahead and use the nested spans. So we'll make a few modifications to the code here. One of them here is I'm simply going to take in I as a number in this function so we can keep track of what dice roll it is. So we'll go ahead and pass in the I value down here in the roll once function. What this will allow me to do is actually make a better span name. So we'll go ahead and create a span up here. So that's going to be return. Then we do trace and then start active span. Tracer, and then start active span here. And then we'll go ahead and use a template literal for this name. And I'll simply say roll dice, and then let's go ahead and give this the name. And then we'll pass in the value of I as well. We'll go ahead and provide this with the function now. So span like so, like we did before. Then we can go ahead and encapsulate our work within this. Now, one thing I need to do is I'm just going to make this a little bit more complex of a function. So we'll say const result here equals math.floor. That way we can go ahead and do the span.end before we return the result. and then we can go ahead and simply return result like so, and go ahead and save that. So what we've done there is we have created a nested span from roll once, since roll once is going to be called by roll the dice here. So essentially what OpenTelemetry is going to do is it's going to handle creating the parent-child relationship from these. So essentially we'll know that this roll once function was run by this roll the dice here, as it's now attached to this span as well. Another cool thing we can do is we can actually attach some attributes now. So attributes let you attach key value pairs to your spans, just so it carries some more information about the current operation that you are tracking. Now you can do this in multiple ways, but one of the simplest ways is simply to go into one of the functions that you want to add some attributes to, and we can use the span object that we have in this function here, and you can go ahead and do set attribute like so. And then we can give this something like, let's say if we call this 𝗖𝗵𝗽𝗀𝗀, and then we can go ahead and then do the result as well. So if I go ahead and just put this below the result, we can actually go ahead and attach what the number of the result was into this span attribute here. And we'll just go ahead and make sure that's a string like so. So that's one way you can set the attribute. Another way you could set the attribute is actually on the active span function itself. Just before you run this function here, you can go ahead and provide it some configuration options. And then in these configuration options, you can provide an attributes key. And then in the attributes key, you provide it an object of the attributes that you want. So if I go ahead and say 𝗖𝗵 and then let's say .roles, we can go ahead and then add in an attribute of the number of roles that we needed to do. So I'll just go ahead and say roles and then .toString again, like so. And there we go. You can see the two different methods we can use to add in some attributes. So up here, we set the attribute of 𝗖𝗵Role to result.string using span.setAttribute, or you can go ahead and create an object or configuration options on the actual start active span function itself, and you can pass that in as an argument. Now for the attributes you've used here, we've used some custom strings. Remember, you may want to go ahead and use the OpenTelemetry semantic conventions for some of those more common ones. Obviously, this one here is completely custom. Now, another cool tool we can actually use is span events. These are human readable messages on a span that represent a discrete event tracked by a single timestamp, essentially a very primitive log. So we go into one of our functions here, say I'm in the roll the dice one and we're within the span. What I could go ahead and say is I can say span, and then we can say .add event, and then the event we can simply go ahead and pass through a name, and you could actually go ahead and just write something like some log here, or I'll just say hello, I am a span event. And then you can go ahead and add in some attributes on this as well if you wanted to. So you could go in and add in things like log. I don't want too locale string there. You could add in like log.severity, for example. And then you go ahead and then just type in error. So you can add in your own custom attributes to your events as well. So it's really useful there. And as I said, that's mainly for human readable purposes, essentially a very primitive log. Let's go ahead and spin this up and see what our new spans are looking like though. So if I go down to the terminal, let's go ahead and expand this. Let me go ahead and run the application using that same command we used before. And then I'll go ahead and send one request in Insomnia, and we should see a few more spans now since we have our custom setup. So if I go ahead and hit send on that, after a few seconds, we're going to go ahead and see some more spans coming in. So this one down here that we've got, that's from the auto instrumentation with the instrumentation.http now. But if I scroll up, you can see we've got another one, and this actually has my span event on it with hello, I am a span event, and you can see we've got the custom attributes there. Then we've got the attributes on my custom span here of the amount of dice rolls we did, so that was 4. And then you can also see up here for each dice roll, we got one as well. So where we've got 𝗖𝗵.rolled2, you can see that's coming from the span I created up here, and we'll have about 4 of them as well since we requested 4 rolls, and you can see it's printing out the result of the actual random roll there. Now, the last thing to check out in traces is going to be statuses and exceptions. Now, statuses can actually be set on a span, and they're typically used to specify that the span has not completed successfully, so that it is errored out. Now, by default, all spans actually are unset, which means it completed without error. You can actually set an OK status on a span though, but that's reserved for when you need to explicitly mark that a span has been successful. So let's go ahead and add in a span status down here. So let's say this function here errored out. We could go ahead and say span.setStatus, and then on this status, we can go ahead and add in a code. Now for the code, you're going to want to use the span status code like so from the OpenTelemetry API, and we'll simply set that to error. And as you can see, we've got the 3 values there of error, OK, and unset. So we'll set that to error. You can also attach your own custom message as well. So we'll say an error occurred or something like that. An error happened. like so. Now, another thing to note with statuses as well is alongside events, it can be a very good idea to record your exceptions as well. Now, obviously this code isn't going to error out as it's quite simple. What you can go ahead and say is you can say span.record exception, and then you could pass through your error there. All you'd have to do is say something like exception, and then you pass that through as an exception imported from the OpenTelemetry API. So if I go ahead and just create a very simple try catch block here, we can say try. Let's go ahead and then do throw an error. So we'll throw, and then we'll simply just say error. Then here we can go ahead and do a catch off the E here, so off the error. And then inside of here, I'm going to add in that span.record error. And then I'll also add in this set status here, just so we can see what this is going to look like. And I'll make sure that's E there for the error. So if I go ahead and rerun my application here, we should see the statuses and the exception occur there. So if I go to Insomnia, I'm going to go ahead and hit send on this. So that's been caught. What we'll see is when we get through a span for the roll the dice in a couple of seconds, we should see that the exception has been recorded on that one as well. So here you can see we've got some attributes here, we've got some events. So we have the span event I created, but then also the exception now gets created as an event as well. And we've got the message that came through with that error there. So that's the exception message. And you can see how that's going to be really useful for your applications and debugging purposes. So there we go, that is the basics of how you manually instrument traces and some of the tools to make them high quality. Let's go ahead and check out our metrics now. So to set up metrics, we do something very similar to traces where we need to go ahead and acquire a meter. And we do this using getMeter. So what we can say is we can say const meter here, and that's simply going to equal to, and then this one here is going to be metrics from the API. And then we go ahead and use getMeter, and we actually provide it with the same information that we provide with the tracer, so the instrumentation scope here. So we'll go ahead and paste that in down below. And we'll also do that in dice.ts as well. So if I come to the top here, we can go ahead and say const and then meter. And that's going to equal to meter or metrics, sorry. So that's metrics from the API dot get meter, and then we pass it with the dice-lib as well. So the instrumentation scope. So we've done the same thing here with tracers, where it's generally recommended to use getMeter in your application where you need it, instead of exporting it in one place and using it across all of your application. So again, we've set up our meters in two places. We set it up in the app.ts, and then also in the dice.ts, like we were using a library, so a valid instrumentation scope. So now that we have the meter, let's look at some of the simple metric tools that we can go ahead and use. Now you will want to check out the documentation to see them all, as there's going to be a lot of them and it's going to vary on your specific use case. But we'll go ahead and check out the simplest form now, which is counters. So counters are just going to be used to measure a non-negative increasing value. So in the case of our example app here, let's go ahead and create a metric to count how often the dice has actually been rolled here. So in our code here, we first need to create the counter. So we'll go ahead and do that outside of the functions here. That's going to be const and then counter, and that's simply going to equal meter. And then we'll go ahead and use create and then counter. One thing to note though is counters can only go up, but you can use an up-down counter as well if you also want to decrease the value of that counter. So we'll go ahead and use create counter for my cases though, as I know it can go up. What we'll then do is we'll call this one dice-lib.rolls.counter. So we just provide it with a name here. And then we can go ahead and save that, and then we'll go and actually use our counter now. So in the function that we want to use our counter from, I'm going to actually be doing this in the roll the dice function here. What you can see is in our for loop, we can go ahead and add in a counter. And what I'll simply do is we can now say counter, and then since it's only an up-down one, we can simply say add here, and then we provide it with the value that we want to add onto that counter. In my case, it's just going to be 1. So that's a very simple counter. And again, if you're using an up-down one, you can actually use .add, but then you just pass it -1. So this is going to allow us to observe a cumulative value that goes up. Next, what we do is we can use histograms as well. Now, histograms are actually used to measure a distribution of values over time. For example, you saw earlier how we report the distribution of response times for an API route with Express, and that's what was actually set up for us earlier in the auto instrumentation. We can actually go ahead and set these up ourselves as well. So we went to app.ts. What we need first is we need to go ahead and create our histogram. So here in our roll the dice endpoint, what we can do is we can say const and then histogram like so. This is simply going to equal to the meter that we added earlier. So it's going to be meter. Then we can go ahead and do create histogram like so. And then in the histogram, we'll add in a name. We'll call this http.server.duration. Now remember, this is actually the one that Express created for us earlier, but I just want to show you an example of how you can create it yourself. Then what you can do is you can also provide it with some options, so the metric options. So what we'll do here is we'll provide it with a description. The description we'll use here is, let's say, distribution of HTTP server response time, since that's what we're going to be recording here. Next, what we can say is we can pass it the unit that we're actually tracking. Here we'll say milliseconds, like so it's going to be milliseconds. And then we can also pass it with the value type as well. And the value type we'll go ahead and get from the API, so it's going to be value type, like so. And then we'll use an integer like that. So now that we created our histogram, we need to go ahead and actually get the time that we want to record in this histogram. To do that, we'll just simply use JavaScript. So this one is going to be const and then start time here. And then we'll simply just do new and then date, and we'll create the new date. And then we'll do .get time like so. Then we also want to record the end time of the function. So just before we return down here, we can go ahead and say const and then end time. And then again, this is going to equal to new date .get time like so. Now we can actually go ahead and get the execution time. So it's going to be execution time like so. And that is simply going to be the end time minus the start time like that. So now we need to go ahead and actually record this on our histogram. And that's as simple as doing histogram.record and then execution time like so. So that's how you create your own histogram there. All in this code here, you can see we create it, we provide it with some descriptions, you can provide it with attributes as well, like we saw earlier on the traces. And then we go ahead and record what we want in this value. So it's going to be a number. And you see for us, we're using the execution time of this function. So we can actually go ahead and start this up. So if I go and now run this code using the new metrics that we just created, I'll go ahead and send one request in Insomnia here. Let's go ahead and expand the terminal. Hopefully what we'll see after a while, because remember we're using the periodic metric exporter, we should see the metrics on our counter, so how many times the dice was rolled, and then we should also see the metrics or our custom metrics on that HTTP endpoint time as well. And there we go, after a while my metrics have been printed out to the console here, so you can see we've got the custom histogram that I set up based on this description here with that unit and the type as well. And then we keep going, we've got my counter up here, so you can see we've got the counter, and then at the moment its value type is the integer. We can see that we've got the attributes, and the current value for it is 4, since I only sent one request and I asked for 4 dice rolls, so my counter is working there as well. And then above here we've got the auto-instrumented metrics as well. That's pretty much all there is to metrics, as there's a lot of different types that you can take advantage of that I won't be able to cover in this video. Do go ahead and check out the documentation. I'll leave that linked in the description down below. But the last thing we want to do is let's go ahead and look at how we can use OpenTelemetry for logging as well. It is worth noting though, the logs API and SDK is currently under development on OpenTelemetry for JavaScript, but the way we're going to be using it, I doubt anything will drastically change, so this should still work. So for logs, I'm actually going to be using the auto instrumentation library again. So if I go ahead and close this and clear it, what we'll be able to do if I just minimize the terminal here, if I go back to instrumentation.ts, if you remember we had our get node auto instrumentations. This actually includes an instrumentation for pretty much all of the popular logging providers. So I'm going to be using Winston, but it also has support for Pino or Pino and then Banyan as well. Now the reason you want to use a logging provider like Winston or something like that is it makes it really easy to implement production grade logging while being really highly configurable as well. OpenTelemetry's goal is not to replace these libraries, it actually wants to work alongside it. So by using the auto instrumentation, we'll be able to inject trace context into the existing Winston log records. So we need to install a couple of packages now as well, as I do need to go ahead and actually add Winston into this application. So for the packages, what we're going to install is it's going to be the SDK for the logs. I'm going to be installing Winston, the logs SDK, but then when you're using Winston as well, you also want to install the OpenTelemetry Winston transport package as well. So if I go ahead and hit enter on that and make sure that installs, the next thing we'll do in my instrumentation.ts is we need to set up our logs now. So for that, we simply go ahead and type in log record processors. This is actually an array, but the first one we're going to use is going to be called simple log record processor, coming from the SDK of logs there. So that's imported from SDK-logs. Then inside of here, again, we're just going to use the console exporter for now. So that's going to be console log record exporter here. And again, we'll go ahead and switch that out for the OpenTelemetry protocol one in a bit. But now I can go ahead and save that. We obviously need to make sure we have a comma there just to make sure that's a valid object. Now what we can do is we can set up the Winston logger itself. So if I go to app.ts here, at the top, what I'll do is I'll say import. We'll import Winston from, and then that's going to be from Winston. And then I'll go ahead and set up the logger. So it's going to be const logger here, and it's going to equal to winston.create, and then a logger like so. Now, since I've added in the transport layer already and the auto instrumentation, I don't need to do anything else to this. I don't need to set up the transport. It will do that out of the box for me. So if I go down to where we have our console log for starting up the server, I can go ahead and replace this with something like logger.info. and I'll get rid of this .log here. So that's now using Winston for my logs, and I can go ahead and start up my application now. So if I go ahead and just run the application the same way we have before, we should see that it comes out looking like an OpenTelemetry export now, and you see that there. If I expand the terminal, we have listening for requests on HTTP localhost 8080. You can see we've got the body of the log itself, but then you can see we've got the instrumentation from OpenTelemetry here, so it's using the Winston transport implementation, and you see it's gone ahead and injected a load of context into this log message for us. So it's added in the things like our service name for OpenTelemetry, the service version, and then also things like the process and the host architecture and a load of stuff like that. You can see how easy that is to get set up thanks to that auto instrumentation library. So there we go, that is how you get set up using traces, metrics, and logs with OpenTelemetry in a Node application. You can see just how easy that is with the auto instrumentation library, and also how easy it is to create your own custom ones as well. But now let's go ahead and look at what we should actually do with these traces, metrics, and logs instead of just printing them out to the console by going ahead and configuring our exporters to send this data off to the OpenTelemetry collector, where you can then go ahead and forward that data to an observability tool of your choice. So then, to send this all to the OpenTelemetry collector, all we need to do is go into our instrumentation.ts file, and where we had the console span exporter here for diagnostic use, we can go ahead and replace this with the OpenTelemetry protocol exporters. First, we need to go ahead and install them though, so I'm going to go ahead and paste in this command. So this one here is installing the exporter for traces using the OpenTelemetry protocol. It's doing the same for metrics and logs as well, so go ahead and hit enter on that. Once that's installed, we can go ahead and use these. So the first one we'll do is the trace exporter here. All we need to do is replace this with OTLP trace exporter like so. We'll do the same for the console metric exporter. We can simply type OTLP and then metric exporter. And then finally, we can do the same for the console log record one as well. This is going to be OTLP and then log exporter like so. It's worth noting you can provide some configuration options for this. If you're running the collector locally, you actually don't need to change anything here if you haven't changed any of sort of the default configuration options for the collector. But say you changed the URL or something, or it was hosted elsewhere, you can actually provide the URL for where you want your traces, metrics, and logs to go as well. Since I'm going to be using a very simple Docker setup, I'm going to go ahead and get rid of this and just leave the defaults. So now let's see what this will look like when we send it to the collector and BetterStack.com. Now in this tutorial, I'm not going to focus too much on how we set up the collector. I actually have a longer video coming out about the OpenTelemetry collector. But the first thing you're going to want to do is head over to the BetterStack documentation. I'll leave a link to this in the description down below. And this actually has a basic guide for getting set up with the OpenTelemetry collector. Now follow this if you want to install it locally, or just follow this video if you want to use the Docker setup for it, which I'm going to be using. But essentially, if you're using Docker or you already have an OpenTelemetry collector, you can click already have OpenTelemetry collector running here. And all you need to do is go ahead and configure these exporters and processors. But first, you'll want a BetterStack.com account as well. So let's go ahead and click sign in here. But first, you'll want a BetterStack.com account as well. So if you don't already have one, go ahead and sign up. It's completely free to start. I'm going to go ahead and sign into mine. Once you've signed in, you should see a telemetry page. As you can see here, we're on telemetry. You can go to the sidebar, telemetry, then sources. We need to create a new source. In connect source, we'll go ahead and call this one Otel. Then under platform for logs and metrics, we can go ahead and select OpenTelemetry. Worth noting, traces are coming soon. If we go ahead and click connect source then, you may want to take note of your source token down here, but we'll go ahead and configure this using the documentation now. So back on the documentation, since I'm already going to be using OpenTelemetry collector with Docker, all I need to do is go to this already have OpenTelemetry collector running. For the source token, you can actually go ahead and pre-fill this, because otherwise you'll just have to replace this value with the one I told you to remember earlier. But in our documentation, you can actually go ahead and select the source we just created for your account, and it's going to go ahead and pre-fill that for you. So I need to go ahead and copy this now. Then I'll head over to VS Code. I have a collector config.yml. Where we have exporters, I need to replace all of the code under here with the one that I have set up. So I'll go ahead and paste that in. And if we scroll up, what you should see is we have our exporters for BetterStack.com here. And if you're going to be using the basic configuration and you want what we just configured in our application to be sent to the OpenTelemetry collector, you also need to have this configuration here, as this is setting up the OpenTelemetry protocol receiver. So it goes ahead and actually receives your traces and your metrics and your logs via the exporters we just configured. Another one that's worth pointing out though is you may want to add this Prometheus configuration up here. This is for scraping metrics from the OpenTelemetry collector itself, so you can get some really cool metrics on what the OpenTelemetry collector is doing. And if you do that, down here what you're going to want to do is add into your metrics receivers. You're going to want to add in that Prometheus name as well, like so, and go ahead and save this. So now that we have that set up for BetterStack, let's just go ahead and run this in a Docker container. So for that, you can paste in this command. It's going to be docker run. We're exposing the ports we need. Then we're giving it the collector configuration that we need as well. And we're running the Otel OpenTelemetry collector image as well. So we can go ahead and hit enter on that. Now, once that's spun up, we'll go ahead and also launch our application as well. So all I need for that is to run the instrumentation.ts again with that import command and then run the application in the usual way. So I'll hit enter on that. Once we've got that up and running, you may notice we don't actually see any log messages here, nothing from Winston or anything like that. That's because the way I have it set up, I haven't added in the console transport or anything like that for Winston. It's sending all of this, and all of this is being gathered by the OpenTelemetry collectors here. So this exporter is sending all of the information to the collector. Nothing is printed out to the console at the moment. So let's go ahead now and see what this looks like in BetterStack.com. But first, let me just send a few requests to the endpoint as well so we can see some of those metrics working. Back where we left off in BetterStack.com then, if you remember, we created our source. If you scroll down, you should see that some of your logs have been received and also your metrics as well. So we go ahead and click the live tail here. What you should see is we have that one log message that we set up with Winston earlier, and that's listening for requests on localhost 8080. And you see it's a very simplified view of what that log message is. But you can go ahead and expand this as well if you want to view the attributes that are on it. So you can see here we've got the attributes, we've got the message, and we've got the resource. So all of that information we saw in the console earlier is now printed out in this nice UI here, and you can sort of collapse things, and you take advantage of BetterStack's really powerful search querying. And you can take advantage of BetterStack's really powerful log querying, and you can even create some new metrics based on your log messages as well. So say we wanted to find all of the log messages for this service, we can go ahead and click this, and that will go ahead and filter all of our log messages for just that specific service there. But we can also see our metrics in a nice dashboard as well. If you go to dashboards, there will be one created for you when we actually created this source for OpenTelemetry, and this is actually for that Prometheus collector within OpenTelemetry collector that I just showed you earlier. And you can see here, this is going to be the information on the OpenTelemetry collector image itself. So it shows you that it's up, and it shows you how many metric points it's sent and various different things like that. But what if you wanted to create your own chart for your own metrics? All you have to do is go up here, click create chart. What you can see here is we actually have our own custom metric here, so that dice lib rolls. Using this nice drag and drop builder, we can actually go ahead and just remove what was already there. Let's go ahead and drag in our dice lib rolls counter total. So this is the one that we set up earlier. Now I'm actually going to change this a bit as it's actually a value. It's not a rate. And we don't actually need sort of the average. We can just take the last here. And you can see that we've now got 80 dice rolls, as this is what I sent earlier when I spammed the request. Within that period, it actually ran 80 dice rolls. So if I open up Insomnia again, let's just go ahead and send a load more requests through, and hopefully this will be captured next time the periodic metric exporter goes ahead and runs. We can also go ahead and save this now, so this chart appears on our dashboard. So we go back to our dashboard, let's go to OpenTelemetry, scroll down, we've now got that any last for that dashboard. Obviously, I haven't had this up and running for too long, but you can actually go ahead and configure the time range as well up here, so we can change this to, let's say, the last 2 minutes or something like that. And there you go, you can see we've got the next round of metrics in, and you can see that our dice roll counter has gone from 80 to 148. So we've got our custom metrics coming through to the BetterStack dashboard here, and obviously that's a way nicer view than the console itself. So there we go, that is how we can use traces, metrics, and logs with OpenTelemetry in a Node.js application. We've seen how we can use the auto instrumentation library to go ahead and get some of these set up for you for popular libraries and frameworks, but we also saw how we can create our own traces, metrics, and logs for OpenTelemetry as well, and then how we can forward that to an observability tool like BetterStack.com. Now, if you want to learn more about what OpenTelemetry is, go ahead and check out this video here, or watch the one that YouTube thinks you'll like. If you have any questions, do go ahead and leave them in the comments down below. And as always, thank you very much for watching.